What is going on, guys? Welcome back to another tutorial. This one we are actually going to tweak our Pengu a little bit. As you can see on the left hand side, we have it going left and right. It blends a little bit in terms of rotation, so we do change our rotation, and we also have the animation state running right here. So if we jump, which by the way we can jump now, we do get the animation running and we get something like this. So we have like a nice little Pengu going on, and that is also what you're going to have on your side when you're done with this tutorial. Alright, so without further ado, let's get right into it. So this is where we left off. We have this Pengu just running around on our tracks. There's 3 tracks, and there's of course a lot of things that can be worked on for this specific mechanic right here. So we're going to be continuing the player motor today. We're going to be adding a really slight rotation when we do take another lane. We are going to have everything we need to just start putting some stuff around the player after that. So let's get right into it. It should be something quite, not easy, but something quite fast to do. So let's go ahead and open up our player motor script. We are going to start with a really easy one. So just after moving our Pengu, what we're going to do is basically just take the position in which we are going and then snap our rotation to it. So let's say rotate the Pengu to where he is going. There's probably a better way to word that, but hey, I'm trying really hard. Vector3 direction is equal to controller.velocity. So this is going to return a vector of your movement. So if you go from point 0, 0 to point 0, 1, then your vector velocity is going to be 0, 1. Now velocity is a unitary vector, so it has a length of 1. It really doesn't matter so much because we're using it for orientation purpose. Something we're going to do before actually using it for orientation is to make sure we don't have any Y component, because at one point we're going to be jumping or we're going to be falling, something like that, so our Y component is going to have a value that isn't 0. And if that's the case and we try to snap our orientation to that vector, then our Pengu is going to be like laying down on his back while he's jumping, and he's going to be just face down when he's falling, which is going to be, you know, kind of weird. So make sure you actually kill the y-axis, so there.y is equal to 0, and then we can say something really simple, transform.forward, so the forward of our object is going to be equal to, we could do there, just like this, so it's going to be equal to this, and you're going to see that it does work, but it snaps to that direction really fast. So instead of having that, what I'll do here is I will simply say vector3.lerp, and I'm going to lerp in between the current position I'm in right now, so transform.forward, and then direction with a really small, say 0.05 float here. So I'll go ahead, and I feel like actually putting that in the float at the top. Let's do that. So private const float turn speed, or something similar to that. Let's take this field, put it here, so we don't have like so many hard-coded values. Oh, actually, we try not to have so many, but we're gonna have some in the end. Let's try this now. So it should be a little bit smoother. I can see it. You can see like that he's coming back after the rotation. So he moves slightly, and this is actually what we're gonna be rolling with. Now, there is something that you're going to realize if you don't follow the same axis as I'm following right now. So the player always move on the z-axis, but if in your case you're moving say on the x or maybe even the y-axis, then you might have a problem where the player is actually, when you're not moving, where you're not actually changing lanes, your player might actually snap back to the original orientation. And that's basically because in case you're stopping a character, the direction is going to be 0, 0, 0, and then it's going to try to bind the orientation to that vector, which means it's just going to be null, so it's going to go back to the default orientation. So in case that, I mean, in our case, it's never going to happen since we're always moving in direction, but just in case you're not using the same axis as I am, and also at one point your character stop, you can simply say something like this. So I'm going to put a if statement. If there is not equal to vector3.0. So if it's not 0, then go ahead and complete these 2 calls right here. If not, let's just keep on going and keep the old rotation you had a frame prior. Okay, so we are now rotating our Pengu. Let's actually tackle the gravity. I am going to squeeze right in between the X and the Y right here, and we're going to start calculating the gravity. So let's actually start by, well, typing in the comments, so calculate y, and then if we are grounded, so if, in this case it's going to be true for now, but if grounded, let's write it here for now. But we'll go back, we'll create an actual function for this, but let's just assume that we are grounded right now. If we are grounded, then our vertical velocity is going to be, say, minus 0.1. Then what do we put? Yeah, so minus 0.1 here. So we always snap to the floor at all time if we are grounded. That is so we can follow down slope, we can make sure our character is directly in contact with the floor at all times. So this is really important. Now on the next step, we're going to be checking if we're actually swiping up or if we're pressing a key. So if, in our case, since we don't have our inputs just yet, let's do if input.getKeyDown, and if we're pressing, say, key code spacebar, then let's go ahead and jump. So here, that would be a jump mechanic. In this case, vertical velocity would be equal to jump force. And just like this, we are going to make our character jump as soon as we change this right here for vertical velocity. You will see what I mean in a second, but before any of that, let's code the else statement. So if we are grounded, go ahead, put a small gravity on us, and if we're jumping, do something about it. Else, we are going to reduce the vertical velocity slowly every frame. So let's do vertical velocity is going to be minus equal to the gravity times time the delta time. This way, the number always goes down when you're not grounded, which makes sense. Here, what you could do, however, if you wanted to make like another type of game or another like more realistic kind of physics, you could say that if that number goes below a certain point, then you clamp it. So basically clamp that number, because in real life you do have something called terminal velocity. In our game right here, we can't really fall like outside of bounds, we can't really fall indefinitely, so I am not going to put this in here. Okay, so let's assume that we are not grounded, so we're falling slowly over time. Now, there is one more mechanic in Subway Surfer that I really like because it's super responsive. If you actually swipe down here, while you're in the air, you can fast fall, which is even better. So here's what we're going to be doing. We're going to be creating a fast falling mechanic. We'll simply do that by saying if in like, for now we don't have the mobile input, so let's do if get key down. If I can type, which I obviously can't right now, get key down. Okay, here we go. If we press on, say, I would say spacebar again, just for now, of course, but later on it's going to be a swipe up for jump and a swipe down for fast fall. Then, if that's the case, let's do a vertical velocity is equal to minus jump force. So whatever power we add for going up, we're going to have it to go down right away as soon as we do the other spacebar. And just like this, we have created a well, different movement mechanics. And they're all around the vertical velocity, so the important thing to do at this point is to make sure we set our move vector.y to vertical velocity. Now obviously you see that something is missing right here. We have some green lines saying that unreachable code has been detected, and that's because we really can't go in here at the moment. Now, the next part of this tutorial is going to be all about writing the isGrounded function. The only reason we are writing our own and not using the one built-in controller, so this one, is simply because it is really not, I wasn't going to say not efficient, but it's efficient. The only problem that we have is that it's updated with physics, which sometimes is going to give you a false result because we're not on the same update loop. Now, unfortunately, we're going to have to code our own one, but it's not going to be so complicated. So let me show you what we'll do real quick. I'll try to type it down super fast. It is a private boolean that we'll call isGrounded. If you follow other tutorial, you probably saw it. We start by casting down a ray, so ground ray. And I'll type it all, and then I'll explain it. So we're going to start by creating a new ray. The ray is going to be shot from a new vector 3. Controller.bounds, center, x, and then we have the other parameter. I'll just split them on other lines. So first parameter is this. That's the x. The second parameter, so the y parameter, is controller.bounds.center.y minus controller.bounds extent y. And then I give it a small offset plus 0.2. And I think I do the same exact thing for the Z. Yeah, so controller.bounds center.z. If you're curious about me looking at, like, I'm actually looking at another screen with this code already made. Is that all we need? Okay, so that's the first parameter. That is our very first vector3. Now we need a direction, and that direction is simply vector3.down. Okay, so let's quickly go over this super quickly. Basically what we do is we create a new ray. A ray is a 2-parameter object that takes in a original position and also a direction. So my original position is the first parameter, so everything that is on this side of the comma. Now this right here, it takes in the center of my character controller. If we go back real quick in the game, the center of my character controller is obviously exactly right here where my pivot point is in X. So just imagine we're taking the X axis of that. Now if we go back, the Y component is controller.bounds.center.y. So the middle of my bounds center.y, which is right about here. So only think about the Y axis at this point. So it's right here. That's the middle of my capsule. Now what I do after this on this component, I do a minus controller.bounds.extend.y. So that's basically, you could call it the radius. That's like half of the height, and that is always true. So if you ever do controller.bounds.extend.y, that is always half of the height. You could have done half of the height if you wanted to. So that's 0.5. So we go from here and we do minus half of the height, which brings you exactly on this point, exactly where the pivot point is. Then just after that, we do a plus 0.2, which means, so we made it down here. We have this point exactly here in the world space. Now we just bump it back up 0.2. So we're inside of the capsule. And then we have the Z component, which is obviously just the center on the other axis, on the Z axis. So everything works on the X axis for now, like I mentioned. But as soon as we turn like this, now we also have the Z axis. So that's pretty much, that's the origin. It's a little bit above the pivot point. And now the direction is down below, because we're going to be casting a ray from above the pivot point down to the floor. So we have our array. That's basically what it means right here. Hopefully that wasn't too complicated. It probably was. Let's actually debug it real quick. So debug.draw ray. You don't have to do this, but I'll do it for clarity purpose. Here we go. So I'm going to be drawing a ray from the origin to the direction. Let's have a color. So color.cyan. I really like cyan. It's a nice color. And we can also add a duration. So it's going to stay there for 1 second. And just to make sure this works, I'll take is grounded, add a default, like a return false down here, and we'll be putting it in our update loop exactly where it belongs. So on this line right here, line 43 in my case. Alright, so next step, play this. Let's have a look. Do we see the ray? Yeah, we do see the ray. So as you can tell, it is spawning just a little bit above the pivot point. Well, actually a lot above, 0.2 above. And then it points downward. This is the ray we're going to be using to actually have a look at whether or not we're hitting the floor. So that being shown, that being said, we can go there and actually do our calls. So if physics.raycast, we're using ground ray, and then the distance is going to be 0.2 plus say 0.1f, which means in the end that what you see over here, vector down, that is a unitary vector, so it has a length of 1 meter. But we don't want to be casting that far down, else we're going to be like getting calls that says we are grounded even though we're 1 meter above the floor, which is not what we want. So the max distance I've put is 0.2 at first, so we have the same exact offset down, so we have the same exact length that we gain by going up here. So we go down there again, and then we put another buffer of 0.1 just to go right here. It's going to be a very tiny ray, but it has to be very tiny. Alright, so back in our code, if we do hit this, let's simply do a return true, and if we don't, let's keep the return false. Actually, you know what? Let's just do a return of this whole thing. Just like this. So if this function returns it true, then we are grounded. If it's not returning anything, if it returns a false, we are not grounded. That's the logic behind it. Let's actually give this a try. So I'm gonna go in the game, press play, and I have spacebar now I can use. And did you see this? This Pingu is jumping. Isn't that amazing? Look at him go. Real winner. And if you've noticed, if you press spacebar twice, you're gonna see he's gonna fast fall. Right now that's just like a small jump, and if we press again, he's going to fast fall, which is quite cool. Can we actually play with the values? We can't play with the values, they're not public, but if we were to just like temporarily put the jump force and say 14, something crazy, right? We can now have a look at how fast he goes up and how fast he goes down. So that is without the fast fall. Nice curve, and that's with the fast fall. And here we go, so that's the fast fall. It goes straight up and then down. Okay, so the next thing we're going to do is to plug in the animation of our Pingu so it can actually look good while jumping. I'm going to create another section right here for animation, even though I only have one field in here. Let's do a private animator, not animation, sorry, so animator. I'll just call anim. We'll make sure to fetch it in the start, so we'll say anim is equal to get component of type of animator. And then right after that, we are going to start plugging it where it belongs. And really, now that I think about it, we don't need it anywhere else but in the jump as for now. So let's go down in the jump, which is right here. So we'll do anim set trigger. We're going to set a trigger that is basically just saying jump. So jump with a capital J. And what else do we need? We also need to know when we are grounded. So this is if we are grounded. We're going to say grounded. Actually, let's do set boolean instead. So set boolean, and we are going to say grounded. Simple as that. So we're going to set a boolean called grounded, and the value is going to be it should be as grounded, but I don't want to be calling it twice. So what we'll do here is we'll just store it inside of a value. So is grounded is going to equal is grounded, the actual function call. And now we'll check if we are grounded. Then let's go ahead and do this. And we're also going to be putting our is grounded right here. Let's move this outside of the scope so we can know when we're grounded and when we're not grounded based on, well, our function basically. But now our animator is also going to know about this. Talking about the animator, we have to give him some hints of what's going on. So let's click on our player, double click on his animator, and we're going to be playing around with the state machine. It looks a little bit different because I played around it, but basically here is what changed. We had something that looked like this, so as soon as we enter the game, we're going to run, that's fine. And now at any moment, at any state, we're allowed to jump. So let's make a transition in between any state and jump. Make sure we have the proper animation, yep, that's fine. And now in between the state and the jump, we need to create a condition. For this animator to have condition, we need to actually create them in under the parameters. So let's go under parameters, let's create a new trigger. We have one called jump, and we also have a boolean called grounded. Now, in between the any state and the jump, we're going to add a condition right here on the right in the inspector, and that condition is going to be jump. If we have that trigger, which we will when we actually jump, then from any state, it is going to enter this one, and then at this point, we're going to create a transition in between jump and run, and wait until we're grounded. So here is what we'll be doing. We're going to add the transition in between jump and run, and look, are we grounded? If we're grounded, so if grounded is equal to true, then we can go ahead and go back to a running state. Let's actually play this game, see if it makes sense. Okay, no, it doesn't make sense for the simple reason that we have a crazy jump force that I didn't remove. Let me quickly go back, remove the jump force, put it back on 4, then play again. Okay, so we got a running Pingu, goes left, goes right, and he jumps. Really weird way to jump, but we'll just take it for now. And if you have noticed, we're still on the floor right now. We are on the floor, but he waits until he goes back to the run animation, and that's because we don't have an exit time. So he's gonna wait until jump is over before checking that condition on run. We definitely do not want that, so here's what we'll be doing. We'll choose that link in between jump and run and make sure that we remove the has exit time to make sure that basically this animation, the jump animation, is interrupted at any moment. It doesn't have to finish its animation, it actually can be interrupted at basically any moment, and then we can enter the run. So let's press play, let's have a look at this. It's a little bit better. We have to play around with the blending because obviously it takes too long before a Benku or Pingu jumps, and it takes too long before it lands. So we're going to be playing around with the transition in between these by simply doing this. I think we can jump a little bit earlier if we move this around. Hold on, I am looking at it right now. Okay, so here's the blending I came up with after a little while. I had to test it out a little bit. I'm not a pro animator. But like in between any states and jump, I'm going to click right here and then have a look at this. So I took this blue here and I really scroll it down. It has to be super fast. Any jump animation has to be really quick. And then I took the jump and pulled it back so we can start exactly where he lifts his arm. So something like this you see on the right hand side. Oh, sorry, left hand side. Now after doing this, I feel like pulling my camera a little bit closer. So I'll go under camera, put that on. I'll do a divided by 2 again. So we had -5, let's do divided by 2. And divided by 2 over here as well. So we're just a little bit closer to our Pengui. It feels a little bit more personal. And here we go. So we're jumping like this. Cool stuff. Can we zoom in a little bit more? What if we go 0? 0 would work because we have smoothing going on. But here we go. So that jump is a lot better than the one we had a second ago. And we can also blend the getting back into the running phase faster. So I'm going to click this arrow and just make sure this is a really tight move. A little bit too tight. And can we start running right away? Oh yeah, that's good right here. So just play around with your blending. I actually like this one. This is great. Okay, so our Pingu is just flying around now. Okay, so we have a running Pingu that jumps and that also, well, gets back on the floor really quick. And that's actually where we're going to be ending to this episode. We had a little bit of animation to do. We had a little bit of tweaking, of course, at gravity and the grounding. So that is going to be done. Now, if you want to keep on going, press the video on the screen right now. It's going to take you to the 3rd episode where we're going to be implementing the inputs with the mobile. So you'll be able to test it right away on your mobile devices. We're also going to be building on our phone right away because test-driven development is really cool. So thank you so much again for watching, and you can find all the information just to reach us and also to ask more questions, suggest, or join us on Discord in the description down below. We're quite active down there, so if you want to have a chance at speaking to us, asking a question, or debugging stuff, just go down there, poke us, and yeah, that's about it. Thank you so much for watching. Click the video right now.